Equation of a line and its relationship to chemistry. A very important math concept that we use in science is the equation of a line and what this means graphically. This is very important to several topics in chemistry. We'll use examples from chemical kinetics in this video. We are going to be focusing on the math part or the math concepts of this topic, and so it's okay if you don't know exactly what these equations that I'm using relate to in chemistry. You'll discuss those in your chemistry classes. I just wanted to use examples that you'll see in chemistry to help make the connection between the math concept and the chemistry concept as clear as possible. We typically write the equation of a line as y equals mx plus b. The y is the vertical axis, and so the y is the value on this axis. The x is the horizontal axis, and so the x value is the value on this horizontal axis. The slope is defined as the rise of the line over the run of the line. Or, in other words, between any 2 points, the change in the vertical axis versus the change in the horizontal axis. In this picture, you would see that right here. Let's continue on and put some numbers on this. First, we're going to stick purely within the realm of just the numbers without relating it to any particular real-life values to get the idea across. If we have an equation of a line, so for example, this line that we have here, we can see that the y-intercept, or the value at which it crosses the y-axis, this is our b value. Our slope is the rise over the run. The easiest 2 points to see this at is where it crosses the 2 axes. So I would probably choose these 2 points. Any 2 points will do, but these are the easiest. This gives us a rise of 0 minus 2, or negative 2, and a run of 1. So our total slope is negative 2. We can then plug these back into our y equals mx plus b equations, which gives us this as our equation for a line. Now, notice how we could determine these values from the graph. So this is something that in science we're going to do a lot of. We're going to have a graph that, let's say, we got in a lab from running an experiment, and then from that graph we can pull out the slope, we can pull out the y-intercept, and those are going to have scientific meaning to them. Let's do an example of that now. This is an equation that you'll use a lot in chemistry. Since you may not have learned about the subscripts and the concentrations and the signs yet, I'm going to just simplify this a bit to call it C0 and CT. You'll learn about exactly what these are in Chem 1C or wherever you cover equilibrium. CT is the concentration at a given time. C0 is the initial concentration. So this would be an experiment you would run in lab. And it's an experiment where that K is something that you would really want to solve for, that you would want to know. So now we can compare our line to the equation of a line and solve for the value that we're interested in this case, the K. So here we can look at the y-intercept, and we can see what our initial concentration would be. We can look at our slope, and it's going to be the same value as the one on the last slide because I'm using the same line. I'm just putting it in a different context. And so our rise is going to be 2. Our run is going to be, our rise is going to be negative 2. Our run is going to be 1. This gives us the same equation we had last time. But now we can compare and we can see that this negative KT is equal to negative 2. And that means that our K is equal to 2. And then that's a meaningful value in this case. You might say, all you did was switch out the letters. Why is that different from the last slide? And that's actually what I'm trying to get at here, is it's not any different from the last slide. It's not any different from when you did equations of a line back whenever you learned it. It's just now we're solving for something that has physical meaning instead of just this random n value that your teacher asked you to. So in summary, We have the equation of a line is given by y equals mx plus b. We can use this to solve for the slope or the y-intercept. You learned how to do this in whatever algebra classes you had leading up to this class. Now, doing it in a chemistry class is exactly the same as doing it in those algebra classes. It's just that these values now have physical meanings as well. And being able to use the equation to solve for m, or being able to solve for the y-intercept, now lets us solve for those values that have physical meaning. And then you'll discuss all of these different chemistry concepts because there's many, many more, of course, as well in your chemistry courses.